Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we will be talking about u-substitutions for definite integrals. So if you have not watched our video about u-substitutions for indefinite integrals, please go back because I'm kind of building upon what I said on that one before. Now, let's imagine that we have this integral from 0 to 4, 3x plus 4, 1 over 2 dx. Okay, so I have the square root of 3x plus 4. And then, just as before, with any u-substitution problem, what I think is, okay, so I know that if I had x to the 1 over 2 dx, this would just be x or 3 over 2 divided by 3 over 2 plus c. Okay, so it would be very easy. Now, I compare this integral with this one, leaving aside the fact that one's definite, one's indefinite, and I realize, well, I need to make a u-substitution, okay? And basically, I need to make all of this equal to u, because I want to have just one variable being raised to the power of 1/2. So, very simple, I make u equals 3x plus 4, which means that du is equal to 3 dx. Okay, so that's going to be my change of variables. And now I have two options, okay? And I'm going to solve the integral both ways, just so you see that it really doesn't matter. So, way number one is we're going to treat the integral as indefinite. Solve it, and then evaluate it. Okay? So, what does that mean? Well, now that I have my u-substitution, all I do is plug it in. So now I have an indefinite integral, more or less, and I have u to the 1 over 2 du, and 1/3 over here. So this is 1/3. Then multiplies u to the power of 3 over 2. This is 2/3 plus c. Never forget the c, guys, when you have an indefinite integral. So this is 2 over 9 u to the 3/2 plus c. Now remember, I need to go back to x, okay? And I have 2 over 9 times 3x plus 4 to the 3 over 2 plus c. Now, initially though, I had a definite integral, so I cannot have this c right here. Okay, no problem. Now that I solved the integral, I evaluated. So basically all of this is going to be evaluated between 0 and 4. Okay, so I solve the definite integral first, and then I substitute. So this is going to be 2 over 9. 3 times 4 is 12. And then I have 16. Square root of 16 is 4. 4 to the power of 3 is 64. Minus 2 over 9. Then square root of 4 is 2. To the power of 3 is 8. So then I have 2 over 9. Here I have 56. 56 is not divisible by 9. So this is just going to be 112 divided by 9. And that's the solution. Okay? So way number one to solve these integrals is to forget that they're definite integrals. Just don't pay attention to that. We make our u-substitution, we solve the integral, and then at the very end we evaluate it. Okay? The second way to solve it is to change the integration limits when you change x to u, right? So what does that mean? Well, we already said that u was 3x plus 4, and therefore du was 3 dx, okay? We already knew that. Now, we know that before our integral was going from x equals 0 to x equals 4. Well, what we say is, okay, when x is equal to 0, then u is going to be equal to 4 plus 3 times 0. When x is equal to 4, u is going to be equal to 4 plus 3 times 4. So this is going to be 4, this is going to be 16. So what I'm doing is, before the integral went from 0 to 4, because I had x's. Now, my new integral is going to go from 4 to 16. And then within the integral, I'm going to have the same thing as before. I'm going to have 1/3 u to the 1/2 du. Okay, and let's solve this. So of course, this is 1/3, 2/3 u 3/2. Now, I need to evaluate this. So there's no c in this case. I can take the 2 9s as a constant, and now I'm going to have 16 power 3/2 minus 4 power 3/2. This is 2/9, so square root of 16 is 4, 2 power 3 is 64, minus 8, so you can start to see the resemblance, and this is basically 112/9. So, as a quick summary, whenever you have a definite integral, and you look at it and you tell yourself, I need to make a u-substitution to solve this. It's the easiest way to go about it. Okay, have the square root, there's things being added in the square root, too complicated to do anything else. So you will always have two options. Option number one is going to be to forget about the fact that you're dealing with a definite integral. You treat it as an indefinite integral, you solve it just as we explained it in the video before this one. And then at the very end, once you reach this point, you evaluate it with the integration limits that we initially had. The second option is, well, since I'm already changing all the x's to u's, then I might as well change the integration limits as well. So then following this rule, I say, well, if I'm saying before that I was going from x equals 0 to x equals 4, well, x equals 0 means what in terms of u, which is what I did here. What about x equals 4? What I did here. And then you substitute everything. So now you come up with a new definite integral that is completely in terms with u. It is very, very important, guys, that when you substitute the integrand, okay, so what's inside of the integral? The integrand with, let's call it a function of u, you do not keep the same integration bounds. What does this mean? That if I had written this 0 to 4 of 1/3 u to the 1/2 du, this would have been wrong. Okay? So, either you do it like this without the integration limits, or if you're gonna add the integration limits, you need to add them properly. Okay? But this is very, very important because a lot of people make mistakes with that. So, I hope it was clear. If it wasn't, please drop a comment. We'll try to get back to you as soon as possible. We're posting videos every day, guys. So click the like button, subscribe, and maybe even hit the notification bell so you can know when we post more and more videos. We'll be doing that all the time. I'll see you in the next one.